Hello everyone, welcome to Play Physics with Suprativ. Today we are going to deal with a very important, a very interesting chapter of class 10, that is current electricity, right? So let's start. See, this chapter current electricity is based on one of the properties of charges, right? So in order to get into this chapter, we have to know what a charge is. What is a charge? Now charge, it is an intrinsic property of matter. Intrinsic property of matter. Right. When I am saying that it is an intrinsic property of matter, then you should understand that whatever that if something is matter, it will have charges. It will be made up of charges. It is very evident because we know that matter is made up of atoms, isn't it? Matter is made up of atoms, which are further made up of, for time being, which are further made up of three particles, that is electrons, protons and neutrons, isn't it? These electrons, these are the particles which carry the negative charge. How much charge do they carry? Minus 1.6 into 10 to the power of minus 19 Coulomb. Coulomb is the unit of charge. Unit of charge is Coulomb. Here I am writing unit is Coulomb. Protons, they carry positive charge plus 1.6 into 10 to the power minus 19 Coulomb, and neutrons are neutral particles, right? So charge is an intrinsic property of matter by virtue of which an object experiences force in presence of some other object, right? Let me tell you something, like what is the cause of gravity? Why does gravitational force arise between two objects? The cause of gravity is mass, right? Likewise, the cause of electrostatic force between two objects, that is charges, right? We have done this, we know the properties of charge. We will discuss in that section, in the properties of charges section. Then in that part we will discuss further, right? So intrinsic property of matter by virtue of which an object experiences force in presence of another, that is charge, right? Now, where do these charges reside? We have discussed that the charges reside in electrons and protons, right? It is known to all of us that in an atom the nucleus is centrally situated, inside which there are protons, and around the nucleus there are various shells. This is the nucleus, and around the nucleus there are the shells within which the electrons revolve. This is the nucleus. This is the nucleus containing protons. Nucleus containing protons. Remember one thing, these protons, they will reside inside the nucleus only. Generally, they do not come out of the nucleus and take part in some chemical reaction or in the production of current electricity. We will discuss all these things, just keep it in mind. And these are the electrons which revolve around the nucleus. They carry the negative charge. Achha. The nucleus also contains the neutrons also, but the neutrons are electrically neutral. We will not discuss about all this. What are the properties of charges? What are the properties of charges? Very important thing and very conceptual. Properties of charges. First thing, that charges are always conserved. Charges are always conserved. If you write only this statement, you should not be given complete marks, because you have to include that charges are always conserved in an isolated system. Isolated system. What is an isolated system, sir? What is an isolated system? Isolated system means the system which is free from any external influence. A system that is free from any external influence. Like if you have studied conservation of linear momentum in class 9th laws of motion chapter, there we have to study the conservation of linear momentum part. A conservation of linear momentum states that the total linear momentum of a system remains conserved in absence of a net external force, right? So if there is no external force on the system, then only the initial momentum, total initial momentum and the total final momentum remains conserved. Likewise, the total charges remain conserved only in an isolated system in which no external force is coming. Now if you do like this, suppose in this system there is 5 coulomb of charges, right? There is a 5 coulomb charge, and now from some external source you have added some more charges, right? Now you are saying that no sir, earlier it was 5 coulomb, now it is 10 coulomb. See, charges are not conserved. Why is it not conserved? Has conserved means what? Charges can neither be created nor be destroyed. Have you created this extra 5 coulomb charge? Or if I withdraw some charges from here and make the charges from 5 coulomb to 3 coulomb, are we destroying the charges? No, we are passing the charges to some other body. That is known as electrification. We will study after this, right? So charges are always conserved, means charges can neither be created nor be destroyed in an isolated system, right? Second, charges get added up algebraically. Now what is this? ये क्या है भाई? Algebraically मतलब? Algebraically means, suppose in this is a system in which these charges are present, plus 10 coulomb, minus 5 coulomb, plus 7 coulomb, minus 20 coulomb. So what is the net charge present on this system? If you say that it is 10 plus 7 plus 5 plus 20, it's wrong. Added up algebraically means if you want to add up the charges, you will have to add them along with their signs, right? पॉजिटिव को पॉजिटिव लेना है, नेगेटिव को नेगेटिव लेना है. प्लस 10 कूलम, प्लस 10 प्लस 7 minus 5 minus 20. How much it is? 17 or minus 25. That is minus 8 coulomb of charges totally present over here. So the meaning of this statement that charges get added up algebraically means if you are to add up all the charges present at a place, you will have to add them along with their respective signs. If it is positive, then you will have to put it positive. If it is a negative charge, then you will have to put negative, right? Number 3. Charge is quantized. What is this, sir? Charge is quantized. What is quantized? Now, मतलब जो बुक्स में होते हैं या फिर इसका जो मीनिंग है, दैट लिटरल मीनिंग दैट इट कैरीज इज दैट चार्जेस आर ऑलवेज एन इंटीग्रल मल्टीपल ऑफ इलेक्ट्रॉनिक चार्ज. बहुत बड़ा बात बोल रहा हूँ, रुको हम इसको आई सिंप्लीफाई इट. चार्जेस ऑलवेज एग्जिस्ट एज एन इंटीग्रल मल्टीपल ऑफ E. E means charge on one electron. Charge on one electron. That is how much? Minus 1.6 into 10 to the power minus 19 coulomb. Right. Now what does this mean? Integral multiple of charge on an electron. See, let us understand this. Suppose that you visit some shop, right? And in that shop, you went to buy some, suppose mustard oil, right? Now in that shop, mustard oil is available only in packets of 500 gram, right? Only in packets of 500 gram. Now in that shop, can you buy mustard oil weighing 750 gram? Or 1200 gram or 2000 600 gram. Can you buy? No, the shopkeeper has only 500 gram packets. Then he can give you the oil whose weight is an integral multiple of this 500 gram. Right? How will he give you 750 gram? Then he'll have to cut a packet into half, and then he'll have to give you 1.5 packets. It's not possible. Just like that. Suppose a body is charged. It has some net charge. Now, basically, when we talk about charges in this chapter, we will talk about electrons and not protons. The reason I told you earlier, because protons are situated inside the nucleus, they do not take part in anything. Electricity is produced in conductors due to the flow of this electrons. So, we are more concerned about the electrons rather than the protons, right? Now, if there is some kind of charge present in some object, then that charge is present in it due to the presence of electrons. So, how much charge is present in an object? It should always be an integral multiple of the charge on one electron. So, charges are always available as an integral multiple of the charge on one electron, because charge on any object arises due to the charge of the electron. भाई electron से तो charge दे रहे हैं. Suppose I tell you that what is the charge on one electron? That is minus 1.6 into 10 to the power minus 19 coulomb. Right? Now, the charges that can exist in nature, they should be equal to, total charge is equals to an integer into E. E means charge on one electron. Charge on one electron. अब देखिए, minus 1.6 into 10 to the power of minus 19 coulomb, it is the charge on one electron. You can have into 2 coulomb charge, into 3 coulomb charge. If you have 2 electrons, then you will have minus 1.6 into 10 to the power minus 19 into 2 coulomb charge. If you have 3 electrons, then you will have this much of charge. If you have 1537 electrons, you will have this much of charge multiplied. But can you have this much of charge into, suppose 3 by 2? It is not an integer, it is a fraction. So, in order to have this amount of charge, you will have to have 3 by 2 number of electrons, which is not possible. मतलब अब क्या करोगे? 3 by 2, 1.5 मतलब एक इलेक्ट्रॉन और दूसरे इलेक्ट्रॉन को आधे से काटोगे आप? That is not possible. So, charges that exist on this earth, on anything, it should be an integral multiple of the charge on one electron. This statement is known as the quantization of charge, and hence charge is said to be what? Now, quantized. Likewise, like the quantization of mustard oil here, isn't it? You cannot buy mustard oil of 750 gram or 1200 gram or 2600 gram from a shop in which there are only 500 gram packets available, right? So, this was the quantization of what now? Charge. Okay. Fourth property is what? Fourth one is very easy, we know. Like charges repel each other and unlike charges attract each other. Like charges repel means a positive charge will repel another positive charge. Negative charge will repel another negative charge, and positives and negatives, they attract each other, right? Like charges repel, like charges they repel, and unlike charges they attract. These are the properties of what now? Charges. Okay, next. Now, let us know something about electrification or charging of an object. Electrification or charging What is this? Now see. Now since matter is made up of atoms and atoms are made up of electrons and protons, so all the objects in this universe, in this world should have charge. But not always we say that all the objects are charged. Why? Because generally atoms atoms, they are neutral. Neutral. Neutral means no charge. No. Neutral doesn't mean no charge. Neutral actually means equal amount of positive and negative charges. Positive and negative charges. That is, an atom has equal number of electrons, means negative charge, equal number of electrons and protons. Right. Now see what? If you disturb the neutrality of an atom, if you disturb the neutrality of an atom, then the object gets charged up. Right. Let us take example of, we can take the example of sodium and chlorine. You know, sodium, its atomic number is 11. So it has, you know, 2, 8 and 1 electron in the outermost shell, right? And chlorine, it has 7 electrons in the outermost shell, isn't it? It will lose 1 electron to gain stability, and it will accept 1 electron to gain stability, isn't it? Now see, sodium, since it is losing 1 negative charge, earlier what was the scenario? Earlier the scenario was it had 11 electrons and 11 protons, since its atomic number is 11, right? And chlorine, this is sodium and this is chlorine. Chlorine had 17 electrons and 17 protons also. But when it lost 1 electron, again see, only the electrons are involved in all those things. Protons का कोई हम nucleus के अंदर आराम से है, हम आसानी से बाहर नहीं निकलेंगे, right? So electrons will take part. So once it loses 1 electron, now the number of electrons changes from 11 to 10, but the number of protons remains the same, 11. Here it has accepted 1 electron, so the number of electrons has become 18 electrons and the number of protons remains the same, that is 17 protons. Now see, here is 1 proton extra, that is 1 positive charge extra, so it gains a net positive charge and becomes positively charged, what we say, that is Na plus. And this acquires an extra negative charge, which, because of which it gains a net negative charge minus 1. So in order to charge a body, you'll have to disturb the neutrality, you'll have to disturb its neutrality. You'll have to either remove electrons or incorporate electrons within the atom to get charged. We know in the previous classes we have done those experiments when we rub a glass rod with a silk cloth, right? When you rub a glass rod with a silk cloth, the glass rod loses electrons to become positively charged, and the silk cloth accepts those electrons. See, here also conservation of charge is present. You will say, if you think that it is losing electrons, matlab wo to gaya. That is wrong. That does not get destroyed. The charge from the electrons that was lost by the glass rod was gained by the silk cloth, and no charges were created or destroyed. Just the movement of charges has taken place, and it has become what charge now? Negatively charged. So these are the things. There are various other ways of charging. There is charging by conduction, charging by induction. So all these things we are not going to discuss in this. We will discuss more about the current electricity part of one of the properties of this electric charge. So let's move on. Okay. Small numerical problem first. If someone asks you, how many electrons constitute 1 coulomb? 1 coulomb of charge, very easy. So minus 1.6 into 10 to the power of 19 coulomb charge is present in, 19 coulomb charge is present in how many electrons? Sir, 1 electron. So 1 coulomb of charge will be present in, sir, how much? 1 by 1.6, let us take the magnitude only, that is just the 1 by 1.6 into 10 to the power of 19 electrons. So how much it is? So if you calculate, it will be 6.25 into 10 to the power of 18 electrons. Okay. We'll discuss more numerical problems, not on all these, but something else. Now let us discuss a very important topic, that is potential. Right. But before that, let me talk something more about this electricity part, current part. What does the word current mean? What does the word current mean? Current means flow. Current means something which is flowing. You know, in GS there are two parts, you know, we have to study. One is the static decay, another one is the current affairs, those things which are in the news currently, which are flowing, right? So the literal meaning of the word current is to flow. Current means to flow, right? Now in this chapter, whose flow are we talking about? In this chapter, we are talking about the flow of charges, and more precisely electrons. Electrons. So this is the qualitative definition of electric charge, right? But in physics, you know, physics always demands two definitions of any quantity, of any physical quantity. One is the qualitative thing. For example, one is the qualitative thing and the other one is the quantitative thing. For example, I will tell you, in Newton's laws of motion, the first law, Newton's first law, gives the qualitative definition of force, right? It says you that what is force? Now force is something which is necessary to change the state of rest or motion of an object, right? It just gives you an idea कि अरे भाई ये क्या है, कौन सा बला है ये, right? It does not give you a numerical value, and if you cannot have a numerical value in physics, it's of no importance, because you'll have to you'll have to use equations, you'll have to get equations, otherwise it's of no importance, right? The second law, it gives you the quantitative definition of force, by which you can get a numerical value of the force that you are talking about, that is force equal to mass into acceleration. So likewise, this is the qualitative definition of current, that is the flow of charges, or the rate of flow of charges, more correctly, rate of flow of charges. Mathematically, if we talk, see, mathematics is a language of physics. You cannot learn, you cannot teach physics if you cannot explain something mathematically, right? So mathematically, current is equals to, current I is equals to charge flowing by time taken. Charge flowing by time taken. Now, in the next part, we will discuss very deeply about this charge flowing. Charges do not flow on their own. Charges normally do not flow. Charges normally do not flow on their own, but charges have to be made to flow. How it is done, we will see in the next chapter, in the next video, right? For time being, current is equals to charge flowing by time taken. By consider that there is one conductor, right, which is connected to a battery. Now I am telling you that suppose 10 to the power 20 electrons flow in this, through this wire, through this conductor. In which direction they will flow? And let me tell you, in this direction the electrons will flow. Why sir? कैसे पता चला sir? सब बताएंगे, पहले ये समझ लो फिर बताएंगे. There are 10 to the power of 20 electrons flowing through this conductor in time, suppose in 10 seconds. Then find the current through it. Right? Sir, current is equal to charge by time, charge flowing by time. अब कई सारे विद्वान हैं जो इसको ऐसे कर देंगे बहुत एकदम 10 to the power of 20 by 10, जो कि है बिल्कुल गलत. ये चार्ज है. Is this charge? Is this charge? This is the number of electrons. So 10 to the power 20 is the number of electrons. You have to find the amount of charges constituted by 10 to the power of 20 electrons, which is nothing but 1.6. अच्छा सर माइनस नहीं लूँगा, मैग्नीट्यूड ले रहा हूँ, राइट. 1.6 into 10 to the power of minus 19 into 10 to the power of 20 by कितना seconds? 10 seconds. That will be your answer. That is equals to 1 point, ये तो कट जाएगा 1.6 की coulomb. So charges is not charge. Electricity is nothing or current is nothing but the rate of flow of what now? Electrons. Okay. Don't want to make the video very large. It will be. वो क्या होता है ना कि वीडियो का लेंथ देख करके हम डर जाते हैं कि इतना बड़ा वीडियो, कितना कुछ जानना पड़ेगा, सब जानेंगे, right? We will study all the things, but part by part, right? In the next video, we are going to learn. We will start the video with the concept of potential, very important thing, with the concept of potential. We will study about the working or the function of a battery, right? We will learn something about circuits, and then we will move on to Ohm's law and other things. We will have to deal with the combination of resistances, combination of resistors. We'll also see after that, after we complete all those things, there is one more topic. There will be one more topic left, known as the heating effect of electric current. Heating effect of electric current. It was just an introductory class today. I introduced the concept of current, electricity, the concept we discussed about the concept of charges, their properties, and in the next video we will proceed with all these topics. So till then, thank you and stay tuned.